So we are going to define now displacement. First, I'm going to remind you again in the 11th grade how you define the displacement. Remember, your linear motion is defined with respect to a reference point. You define position of an object according to an object which is generally at rest. For example, you can define position of this car with respect to this tree. So this is the initial position of the car, and last year you defined by x initial. And after that, this car is starting to move in one direction and then going to another position. This is the final position. It is x final. And last year you also draw this as a vector. And from initial to position to final position, this directional line is called delta x, which is displacement. This is called linear displacement because object is moving on a line. So, and you studied only this one when the object is displacing on a line. It is delta x, linear displacement. But in here, in circular motion, object is not moving in a straight line path. It's a curve. That's why object is also turning by some angles, like this. So, in 11th grade, we defined the reference point. But in the 12th grade, when we are defining the circular motion, we are going to use not a point, we are going to use a line. Yani reference point. Now in the circular motion, we are going to define a reference line. This is a reference line. Reference line will pass from, start from the center of the circle and will pass from the position of the object, initial position of the object, like this. Here's a cyclist. Cyclist is initially here. So that's why I'm going to draw a reference line which starts from the center, passes through the initial position of the object or the bicycle. But this bicycle is initially here, but then it starts moving on this circular path. And of course, it will move to a new position after some time. So I'm going to draw again a line, but this line will represent the final position. So initially the bicycle is here. This is the initial position. Then bicycle is starting to move on this circular path and then attains a new final position. This is the final position line. And by the time this bicycle moves a distance, this distance is called arc length. We defined this before. And also this bicycle is turning some angles. So theta, angle theta. So bicycle is starting from here and turning with some angles. This S, because continuously changing in physics, if a quantity is changing, we put delta. So this arc length is changing. Now it is here now, but sometime later it will be here. Sometime later it will be here. Sometime later it will be here. This S arc length will continuously change. For that reason, we are going to put here delta S, which is the arc length now defined as delta S. Yani the distance traveled by the bicycle on the circular path is defined as arc length and represented by delta S. By the time this bicycle is turning angles, initially 0, then increases, it's turning by some angles, and angle is increasing as time passes. The angle, delta theta, because it's also changing, that's why we should write delta. The angle delta theta through which object turns is called angular displacement. Basically, we can say that there are two types of displacement here. One of them is the distance. Object is moving a distance on the circle, delta S, which is known as arc length. But also, this object is turning with angles, some angles. This angle, the object turn, is known as angular displacements. Now, questions about this?
Yes, teacher. So for circular path, we use delta S always, right?
Delta S for distance. If you want to express the motion in terms of meters, centimeters, we will use delta S. But if you are going to use this motion, if you define this motion by angle, so we are going to use radian or degree, which is called angular displacement.
Okay, so always for circular distance, we use delta S, which is represented.
Yes,
Delta
by
S
meters.
meter.
Delta S. Delta S is meter, centimeter, but SI unit is meter. But angle will be represented by always in calculation radian. But sometimes they can give you degree. You are going to convert degree to radian, and you know how to convert it.
Yes, thank you.
Definition of angular speed is angular displacement is given in your book like this: the angle through which an object is rotated in a specific direction is called angular displacement. Yani object is turning in a specific direction. This specific direction has a meaning. Now you will learn it, because sometimes this bicycle can turn like this, or maybe it can turn like that. So this turning, this rotation, this revolution, clock is explained by clockwise or counterclockwise, but equation is very same. Remember, I told you that theta is equal to s divided r is the basic equation, and because both s and theta is changing by time, we put delta. Delta theta is going to be delta s over r. This is the equation for calculating angular displacement. R is not delta because r is constant. Here is r, what is r is. Here is also the same r. Here is not same r. R is not changing. For that reason, you are not going to write delta for r. R is constant. R is the same, but delta s is changing. Delta s is increasing as it is moving. Delta theta is increasing as it is moving. That's why theta is delta theta, delta s, but r, there is no delta. So delta theta is equal to delta s over r, the equation for calculating the angular displacement. I told about direction. Yes, directions. We have directions. If object turns in clockwise, counterclockwise direction, both delta s and delta theta will be written as positive. Clockwise, counterclockwise means this: opposite of clock. Clock is turning like this. So if object turns in the opposite direction of a clock, like that, counterclockwise, it's called sometimes counterclockwise, sometimes in some book anti-clockwise, but your book is using this definition, counterclockwise. If object is this bicycle, now it's turning counterclockwise, so its angular displacement, its arc length will be written as positive. But if it is turning clockwise like this, if it is turning like this, in this case you are going to write both delta s and delta theta negative. Yani clockwise rotation or clockwise revolution will be written as negative, but counterclockwise rotation or counterclockwise revolution will be written as positive. That's why angular displacement has positive numbers, sometimes can have also negative numbers. Now when we are solving the problems, you will see how we use them. And one more thing, and in fact I explained this before, but I'm going to explain again. Every one rotation and every one revolution corresponds to an angular displacement 2 pi radian, because one rotation 360, one revolution 360, and every 360 is equal to 2 pi radian. Like what? One rotation of minute hand. Which one is minute hand? This is minute hand of the clock. Every one rotation of second hand. This red is second hand of the clock. Hour hand. The shortest one is the hour hand of the clock. But every one rotation corresponds to an angular displacement which is equal to 2 pi radian, 6.28 radian. One rotation of the Earth, Moon, Sun around their own axis. So Earth is spinning, Moon is spinning, Sun is spinning about their own axis. Every one rotation again corresponds to 2 pi radian. One revolution of around the Sun. Earth is revolving around the Sun like this. Sun and Earth is moving around the Sun. Every one revolution again corresponds to 2 pi radian. One revolution of Moon around the Earth. Moon is also revolving around the Earth. So one revolution of Moon around the Earth again 2 pi radian. One revolution of a car around a circular path. Assume that there's a circular path and a car starts from here, revolves, comes to the same point again. It's again 2 pi radian. One revolution of any object or one rotation of any object always corresponds to an angular displacement 2 pi radian, which is 6.28 radians. Shazad rides on a carousel that is rotating clockwise. Clockwise. When it says clockwise, we will understand that negative. This clockwise represents negative. So I'm going to, yeah, clockwise, negative. So Shazad rides on a carousel that is rotating clockwise. He travels through an arc length. Arc length delta S is given of 11.5 meters, but because it says clockwise, this arc length will be written as negative number. Yani delta S is going to be negative 11.5 because clockwise rotation. If the child's angular displacement is 165 degrees, delta theta, as you see, angular displacement here is given as a degree. So we are going to write it in degree first. However, of course, negative again because it is clockwise. What is the radius of the carousel? Calculate the R. So calculate R. We know the equation. However, here, if you be careful, angular displacement is given in degree, but we don't use calculations, degree in calculations. We should first convert this degree into radian. There were, remember, 3 methods, and you can choose one of them. This time I will use the equation in your book and to also let you get the equation. Angle in radian is equal to pi over 180 multiplied by angle in degree. So we are going to write here 165, negative 165, insert instead of angle in degree. So if you insert it, if you multiply 3.14 with negative 165 and divide by 180, you will get the result as negative 2.88 radian. Now we got the angular displacement in radian. Now we are ready to use the equation. Which equation? Equation for calculating angular displacement. Delta theta is equal to delta S over R. But this equation is calculating delta theta, but question is not delta theta, question is R. Now cross product, change their position. Change the position of delta theta and R. Yani get R here, get delta theta there. This is a very simple rule. So R is going to be, in this case, delta S over delta theta. And delta S is given. Delta theta is calculated. Only write them. Delta S is negative 11.5 inserted in here. Delta theta you got is as negative 2.888 inserted here. And use your calculator. If you divide these two numbers, you will get positive 3.99. So which is because negative will simplify. So answer will be positive. And it is normal because radius never written as negative. It must always be written as positive number. And let's go with the practice problem. Abidal sits at the top of a bicycle wheel and flies away just before it would be squashed. So bicycle wheel is turning, and inside Abidal is sitting at the top, and then as it is turning, so it is flying just before being squashed. If the wheel turns clockwise, clockwise. Wow, right now, quickly, negative. So, and the beetle's angular displacement is pi radian. So this is angular displacement. Delta theta is pi radian. And corresponding arc length for the beetles is 1.2 meters. Arc length, delta S. Delta S, 1.2 meters. What is wheel's radius? Calculate R. This is the question. Now, as we said, let's check the recordings. Yeah, because it says clockwise, both angular displacement and the arc length must be written as negative. So angular displacement is pi radian, which is 3.14 radian, but negative 3.14 because it is clockwise. Arc length is delta S is 1.2 meters, but it is negative 1.2 because clockwise. So calculate the wheel's radius. What is R? Get R. So then we know that delta theta is equal to delta S over R. Arc length divided by radius is angular displacement. Again, we will calculate R. Cross product. Just change delta theta and R's position in the equation. So R becomes delta S over delta theta. Delta S is negative 1.2. Delta theta is negative 3.14. Divide these two numbers, you will get the result as 0.38 meters. So radius of this wheel is 0.38 meters. And now we are going to define a new quantity, a quantity. In the 11th grade, you studied with displacement first. First, you calculated what delta x is. You made some calculations about delta x. But later, you defined the speed or you defined the velocity. Next one. So you said that, yeah, it is delta x over distance over time. It was the velocity. So, or the speed. Linear speed, in the 11th grade, you studied linear speed, or sometimes it's called translational speed because it's defining how fast an object is moving from one point to another. Linear speed or translational speed, which is v, describes how quickly an object or a point moves from one point to another point. Yani car is moving from here to there. So then how fast this car is moving from here to there? If it moves very fast, so greater speed. If it moves very slow, smaller speed. You define this. So speed describes distance traveled in a specified time interval. Yani you in the 11th grade, you defined that this bicycle is moving from here to there and travels a distance which is equal to arc length delta s in a time interval of delta t. You can find its speed by the equation delta s over delta t. Remember, you wrote delta x, but delta x was only for if an object is moved straight line, it was delta x. But if it is moving a circular path, so you say that this is delta s because length of the circle, length of the path is delta s, which is distance. You are going to divide distance by time, and you calculated v speed in the 11th grade. But now we are going to define a different speed, which is known as angular speed, because as this bicycle is moving from here to there, it is also turning by some angles. How quickly this bicycle turns, how quickly an object rotates or revolves, so it is defined as angular speed. It defines the angular speed. So another speed at the same time can be defined according to angle. At the same time, the object turns an angle, delta theta, in a time interval, delta t, and we will define a speed related to circular motion, or we will learn later, rotational motion of an object. We are going to define a speed, but that speed is given a name, angular speed. Basically, angular speed will define how quickly an object is turning, how quickly angle is changing. So angular speed is defining this. And angular speed, of course, if this bicycle is moving from this position to that position, say that in a time interval delta t, by the time this bicycle is turning an angle delta theta, angular displacement is delta theta. Average angular speed is defined as the rate at which a body rotates about an axis. This is definition of average angular speed in your book. So when something starts with the rate, which means you are going to divide a quantity by time interval. You are going to divide a quantity by interval. So rate means this. Average angular speed describes how quickly rotation occurs, also defined as rate of rotation. How quickly object rotates, how quickly an object turns. So average angular speed defines that. And we can calculate average angular speed by the ratio of angular displacement delta theta to time interval delta t. When it says ratio, you are going to draw a line. Ratio of what? Delta theta to what? Delta t. So this defines average angular speed. Yani delta theta over delta t is the equation for calculating average angular speed of an object which is turning on a circular path. So in here, What is the unit of average angular speed? We know that the angular displacement is in radian. Time interval is in second. That's why average angular speed will have a unit which is radian per second. And because delta theta can be positive and negative depending on rotation is clockwise or counterclockwise. So angular speed can also be considered positive and negative. So angular speed positive for counterclockwise rotation, and it will be negative for clockwise rotation, just as delta theta and delta s. So delta s, delta theta, and omega, three of them. It's positive if rotation is counterclockwise, negative if rotation is clockwise. Sample problem 1b. Raskar spins on a stool. Stool is a chair which can rotate. Stool is a chair which can rotate. So Raskar spins on a stool in a counterclockwise direction. Positive. We get average angular speed of 4 radian per second. Average angular speed, omega. In what time interval? Time interval, delta t. In what time interval? Questions about delta t. Will Raskar's feet have an angular displacement of 8 pi radian? Angular displacement, delta theta is given. So, and all are given, so we are just apply the equation. Average angular speed is 4 radians per second because counterclockwise rotation positive 4 radian per second. And angular displacement delta theta is 8 pi radian. It's also positive because counterclockwise 8 pi radian. Of course, instead of pi, we are going to write 3.14 in solution. And calculate the delta theta time interval. What is delta theta? We will use the definition of average angular speed. Delta theta over delta t. And of course, we will get delta t, not omega average. Delta t is going to be delta theta over omega average. Delta theta over omega average. Delta theta 8 pi. Pi is 3.14, we know. So we are going to write 8 times 3.14. And omega average is 4 radian per second. Instead of omega average, write 4. So 8 multiplied by 3.14 divided by 4 will give us time interval, which is 6.28 seconds. So Raskar's speed will move 8 pi radian in 6.28 seconds. This is the solution of sample problem. Another practice problem. Let's continue with problem. A car tire rotates with average angular speed of 29 radian per second. Average angular speed, omega average is given 29 radian per second. In what time interval? Again, delta t is asked. In what time interval, delta t, will the tire rotate 3.5 times? This 3.5 times means this tire, whatever, is turning 1 times, 2 times, 3 times, and a half, which means 3.5 rotations or 3.5 revolutions. It's turning. Yani 3.5 times means 3.5 revolutions. So that's why now we should do it. Revolution, do we use revolution in calculation? No, we have to convert this revolution to radian before making calculation. Time interval delta t is asked. Now, first I have to convert this into radian. How? Every rotation or every revolution is how many radians? 6.28. I am going to multiply this revolution by 6.28 to get the radian. So 3.5 revolution, or it can be a rotation too, 3.5 rotations. Yeah, times means this. If I multiply it with 6.28, I will get the result in angular displacement, which is equal to 22 radians. And now we can use the definition of average angular speed, which is omega average is equal to delta theta over delta t. Questions delta t, again change delta t and omega average Delta theta over omega average is delta t. Delta theta is 22 radians. We inserted 22 in here, and omega average is given as 29. We inserted in here 22 divided by 29. Time interval is 0.76. I want you to get familiar with the clock. Clock is sometimes, because we don't use such clocks after now. I mean, everybody using digital clocks. Yeah, this is the second end, which is, as you see, moving faster. Second as is angular speed of second end is faster, but minute hand is slower. Which one is slowest? The hour hand is the slowest. So this is the clock. And second hand of a clock completes one rotation in how many seconds? In 60 seconds. Minute hand of a clock completes one rotation in 60 minutes. And this middle one is completing one rotation in 60 minutes. And sometimes we need to convert this minute into second. 60 minutes can be converted to second by multiplying 60, because we know that every minute is 60 seconds. So 60 minutes is 60 times a 60, which is 3,600 seconds. But our hand, the shortest one, the slowest one, completes one rotation in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 hours. So our hand of a clock completes one rotation in 12 hours. So again, second hand completes one rotation in 60 seconds. Minute hand completes one rotation in 60 minutes, but our hand completes one rotation in 12 hours. How 12 hours can be converted to second? Yes. All right. This is a chapter review question, also a ministry exam question. How long does it take the second hand of a clock to move through 4 radians? Yani second hand of the clock will move 4 radians in how many seconds? You are going to calculate this. But we learned that one rotation of second hand takes how many seconds?
60.
One rotation. Yeah, one rotation takes 60 seconds. Tell me, what is the angular displacement for one rotation?
6.28.
Yes, 6.28 radian is angular displacement for second hand takes 60 seconds. Yani 6.28 radian rotation completed in 60 seconds. 6.28 radian angular displacement is completed in 60 seconds. So question is what? 4 radian takes how many seconds? 4 radian takes how many seconds? Cross product again cross product. So then you will say that x multiplied by 6.28 is equal to 6 multiplied by 4. Then divide by 6.28. Divide by 6.28. Simplify them. You will get 4 multiplied by 60 divided by 6.28, which is 38.2 seconds. So this is the answer. 4 radian rotation takes 38.2 seconds. This is also very important type of question in ministry exam about the angular speed. A cyclist rides along a circular track. There's a circular track. A cyclist is riding on this circular track. A cyclist travels around exactly half the track. Half the track means cyclists are starting from here, not completing the circle. What is this called? It's called semicircle, is it? Semicircle. Yeah. What is angular displacement for semicircle? What is angular displacement for semicircle? Pi radian or 3.14. Doğru. So angular displacement will be in here, pi radian or 3.14 radian. In how many seconds this takes? 10 seconds. And delta t. This is delta theta, this is delta t. What is average angular speed? Omega average is equal to delta theta over delta t. Because for half revolution, angular displacement is 3.14 radian divided by time interval 10 seconds, which is 0.314 radian per second is the answer for this question. Find average angular speed of Earth about the Sun in radians per second. Hint, Earth orbits the Sun every 365.25 days. Yani this is Sun. Earth is revolving around the Sun, and this revolution takes 365.25 days. This revolution is called time. This time is called 1 year, correct? 1 year. Earth is completing one revolution around the Sun in 1 year, which is 365.25 days. This is delta T. Delta T. But what is one revolution is equal? What one revolution is equal to in terms of angular displacement? Orbiting once means one revolution. And we know that one revolution is equal to 6.28 radians. 6.28 radian. Your angular displacement, delta theta, is 6.28 radian. What about time for this one revolution? It is 365.25 days. You should convert this to second. How? Every 1 day is equal to 24 hours. Every hour is 60 minutes. Every minute is 60 seconds. You should multiply this by to convert the time interval to seconds. Then you are going to calculate average angular speed. Delta theta divided by delta t. Yani 6.28 divided by 365.25 days. But every day is 24 hours. Every hour is 60 minutes. Every minute is 60 seconds. But don't forget to put the bracket. 6.28 divided by bracket 365.24 multiplied by 24 multiplied by 60 multiplied by 60. Now close the bracket. Get the answer. 1.99 times 1.99 times 10 to the power of negative 7. 10 to the power of negative 7 radian per second. This is the average angular speed of the Earth around the Sun.